Okay, so we're going to do 1.3 part two, which is something that I know we all love, and that's word problems. This is actually the way we think about algebra out in the real world because you don't go into a job or at a restaurant or something and say, I want 3x of those plus $5. You say it verbally. And we have to make those verbal models, um, and it takes some practice. Now, we start out with hopefully what's easier problems, and later in the course, we get into more and more difficult problems. All right, let's take a look at number one here. It says a salad bar charges 350 for an empty container. Then you will be charged 45 cents per ounce of food. The following model represents the complete cost of your shopping trip to the store. So to make a verbal model, we're going to take first of all, they give us the variables here. We don't have to assign the variables. And yes, we're going to have to do this for every problem. Make a verbal model, define the variables, and then come up with the actual algebraic model. A lot of times, students will do this in their head. And they're like, well, I can give you the answer right here. Well, that's not what we're going to grade you on in Algebra 2. We're going to grade you on the verbal model, the variables, and the algebraic model, not if you can get the answer right. Okay, so let's do, again, let's go back to this. It says the following model represents the complete cost. Now, they're fortunate enough to give us the model this time. Now, here's our model, is that T equals 3.5, or $3.50 for our empty container, plus 45 cents per ounce of food. Now, T's probably the easier one here, okay? The following model represents the complete cost. So here's our T. I know students will normally put, well, that's the total cost. A lot of times, most of the problems will say total cost, but this one says complete cost. So we have to be really detailed here. We're going to do complete cost. That's the complete cost. And then we're looking at these variables here. And these variables in their model that they give us, which normally they don't, is C and D. So we have to figure out what C is. Now, C, let's go back here and look at the first part here. It says $3.50. So here's my $3.50 for an empty container. Now, many students, this is where they make their mistake. They'll just put down, well, C is the empty container. It's not just an empty container because it's $3.50 for each empty container. So C, we're charging it by the 350. It's the, well, if we have one empty container, it's 350. If we have two empty containers, it's 7. If it's 3 empty containers, we have 1050. So C is the number of empty containers. And if you want to use the hashtag symbol, doesn't mean anything about the internet. That is the symbol for the word number. It'll save us some time later. And then we have to worry about this other last variable. We have to define that. It says here, you will be charged for 45 cents per ounce of food. So ounce is a weight. So again, it's the number of ounces of food. So those are my defined variables for that particular problem. And it gives us kind of a flow chart for these real life problems of what we're actually doing here. Is we're going to write a verbal model. That's what we did up here. And then we're going to assign the labels. Well, they did it for us, T, C, and D. Write an algebraic model. Well, this is our algebraic model up here. They also did that for us. Then we're going to solve the algebraic model and answer the question. So a lot of that was done for us in this example up here. Now it's time to actually put this into action for ourselves. So it says a personal, okay, I'm going to scoot this up a little bit. I had to move my camera. A personal trainer charges $20 per month for clients, plus a $17 charge per hour for each session of training. Okay. Create an algebraic model. So this time we're going to have to create that equation. Create an algebraic model that determines this total cost C. So they're actually giving us, again, they're assigning the variables, total cost C, my C, total cost for a single month of personal training for an unknown number of hours H. So they're going to give us an H too. So here's an H. We're going to have to figure out what H is. C, again, they already told us what C is. It's total cost. But let's do our verbal model first. Okay. Total cost is going to be made up of, well, $20 per month. So there's a monthly service charge for the clients. So there's a monthly charge for the personal trainer. And we're going to add to it $17. So let's add to it $17, which is the charge per hour. So it's hourly charge times, and again, we don't know how many hours it is, so that's why we're going to have to put that, that's where that variable is going to come in. Okay, that's going to be the number of hours. And I'm going to use my little hashtag, number of hours. Okay, so C is our total cost. They gave us that. And H is the unknown number of hours. They defined that for us already. Okay, so let's go ahead and now take our verbal model up here and make it algebraic. Well, I already put the C in there, so we'll start with that. C equals monthly charge, which is $17. 17 was our monthly charge, plus our hourly charge. Oh, I'm sorry. That was not 17. 17 was our hourly charge. The $20 was the monthly charge. $20 was the monthly charge. 17 was the hourly charge. And then we're going to multiply that by the number of hours, which is our H. So there's my algebraic model. 20 plus 17 times H. So now we're going to actually evaluate this when they tell us that, hey, this person used 7 times or 7 hours this month. So let's go ahead and plug that in. So our cost, our total cost, is going to equal the $20 plus the 17 times, and if you want it, you can put a little times there. I use dots, times H, which this equals our H, 7 times. Okay? Many students will put parentheses, or dot, doesn't matter. So 17 times 7, let's see, 49, 4, 7, 119. If we add those together, it's going to cost $139. Seems to be quite a bit for some personal training. And by the way, again, in real life, we wouldn't be saying, well, $20 plus $119, $139. You would say, hey, this is costing her $139 for a personal trainer. And we should actually write that sentence out. Okay, number 3. You have $650 and you're buying some movies on DVDs that cost $15 each. Write an expression that shows how much money you have left after buying N movies. Okay, so we're going to make an original verbal model, and we're going to start by the original amount. So our original amount, and then we're going to buy some DVDs. So we're going to subtract the cost of each DVD. We're going to subtract the cost of each DVD, and we're going to multiply that by the number of DVDs that we buy. Makes sense. Okay, and that's going to give us the amount left. So I got my original amount, and I'm going to take from that amount, buy some DVDs, times it by each DVD by 15, and then that's what I'm going to have left. So let's assign some variables. Okay, I'm going to assign, I'm going to use N because they told us we have to use N movies. So I have to use N, and that's going to be the number of DVDs to buy. Okay, so I start with my original amount. Now I got to make my algebraic model. My original amount, which is you have $650. $650. And I'm going to subtract the cost of each DVD. See, the cost of each DVD is $15. And I'm going to multiply that by the number of DVDs, which is N. Clean this. Well, if you want to clean this up, that's fine. So I have 650 minus 15 N. So there's my algebraic model. So no matter how many DVDs from person to person, this person buys 30, this one will buy 20, I could just put in for n, the number of movies. Now in this problem, they say n is equal to 23. So I just plug in 23 where my n is. I have 650 minus 15. When I do substitutions, I like putting parentheses in. 23. It's going to equal 650 minus, and this time, I'm going to need a calculator for this. So 23 times 15, I get 345. And taking that away from 600, I'm left with $255. Number 4. Now, number 4 is a little tricky. Okay. It says here your team is setting up a computer program for a popular coffee store. At this store, if you make a single $4 donation, each drink costs $2.40, but the first 3 drinks are free. So we're going to have to figure that out when we go to make our algebraic model. Okay. Then it says, using T to represent the total cost and C to represent the number of drinks ordered. So right away they have some variables assigned. Create an algebraic model to calculate the customer's total bill. Assume everyone will order at least 4 drinks. Okay, so here's my verbal model. Okay, total cost. That's going to equal, well, let's see, we got to give up a donation fee of $4, so there's a donation fee. And we're going to add to it, let's see, the cost of 1 drink, because there's at least 4. So there's a cost of at least 1 drink. So we need to find out what that cost is when we go do our algebraic model. And we're going to multiply that by, let's see, we're going to need, we got the cost, and we're going to multiply that by the numbers of drinks. Not just the number of drinks, because we get the first 3 free. So if we just put the number of drinks, we're going to actually pay for the free drinks. So it's the number of drinks that we end up paying for. So number of drinks we actually pay for. Okay, this is going to be a little tricky to set up in our algebraic model. All right, let's assign our variables. Let's see, T represents total cost. That one was easy because it was given. And let's see, donation fee is given, cost of 1 drink is given. So the only other variable have is the number of drinks we pay for. Okay, so I'm going to use, I don't know, C. Oh, wait, we have to use C. They say that. So C equals the number of drinks ordered. So we actually have to figure out of what we ordered and what we pay for. So let's go ahead and start setting this up. Let's see, total cost T equals donation fee. Let's see, our donation fee was $4 plus the cost of 1 drink was given to us. Now, this is where we're going to have to figure out how we pay for the drinks, the number of drinks, with the first three free. So here's the number of drinks ordered. Suppose I order four. We're going to have to subtract from that those three drinks that are free. So the number of drinks ordered, it says at least four, so we have to pay at least one. So those number of drinks ordered, but minus the first three drinks. So there's our algebraic model. Let's take a look at the last one. A gift shop advertises they will engrave any gift purchased at their store at the rate of, let's say, it sounds like there's a typo here. Engrave any gift purchase. Their store at a rate of 6 cents per letter, and the first three letters are free. A desk plate sells for $22. Write an expression for the total cost of buying a desk plate and having it engraved. So our verbal model is going to be our total cost again. That's going to equal. Now, let's see. What do they have as our fixed cost here? Well, you got the cost of the plate, the desk plate, right? Let's see, cost of plate. And added to our cost for this desk plate is going to be let's see, the rest of the, let's see, we get six of the first letters, 6 cents. So we need the cost per letter. So the cost per letter times, now we get that, again, like the previous problem, we're going to multiply that by the number of letters that we pay for. And again, we're going to have to deduct those letters we don't for the total cost of the letters we have to pay for. So here's our variables assigned. See, I'm going to use T for total cost. And we need a variable. This is a fixed cost, $22. Cost per letter is fixed. That's 6 cents per letter. What's not fixed is, and what changes is the number of letters. So I'm going to use N for the number of letters that we pay for. Okay, so here's my algebraic model. T equals the total cost equals the cost of a plate. The cost of each plate sells for $22 plus the cost per letter was a fixed cost of 6 cents. Okay. The number of letters, which is N, but we get the first three letters free. So I got to take those three letters out of there. And this is my algebraic model. Now I know these seem a little easy to do. And like I said, most students are going to want to do this in their head. But we got to learn how to make these models, because these problems later are going to become really, really difficult. Okay, so we need to know the basics of of how to make these models from scratch. And really, these verbal models help us understand what's going on.